Hi, this is Simon Obstall and welcome to another tutorial for Blackmagic Fusion. And today we're going to be taking a look at making this. So there are quite a few techniques involved here that I think you're going to find interesting, and as usual it involves quite a few expressions. So let's get started. Right, to start with, let's add a 3D shape and let's turn it into a cylinder. Let's have a look at it. So for the height, I want 1. This is very important. Turn on both bottom and top caps while we're at it. And for the radius, I want 0.025. And then I want to add another 3D shape, and this is going to be a sphere. And let's merge the two together and let's look at the result. Sphere is much too big. Let's reduce its size down to something like 0.05. Come to transform. Y translation is going to be 0.5, so it's sitting on the top there. And then I'm also going to take this and I'm going to add a 3D duplicate. What we want to do is to have a Y offset of -1. And now we've got a ball at both ends. Then we can take the merged result and add another 3D duplicate. Let's look at that. Let's have 4 copies. And let's come down to the rotation and rotate it through 90 on Y. And the reason we're not getting what I want is because we need to move this merge center. So let's move it to -0.5 on X and also +0.5 on Z. And now we've got the array around the center of the world, and that's really important. So then let's add to this final duplicate another 3D duplicate. And let's look at that. Let's come to the rotation and rotate it through 90 on X. And let's add another 3D duplicate, but not to the end of the other one. So let's pipe this one into it and merge that over the other one. So here we want to rotate it on Z through 90. So now we've built up the cube. Obviously there's some duplication of the shapes, but I'm not really particularly worried about that given how we're going to actually render this thing. So then I want to add another 3D merge to the end of that. I want to look at it. I want to add a 3D camera to that merge. That's with this merge viewed in the viewport, right click and select camera and then copy POV to camera. And then to the output of that 3D merge, we're going to add a 3D renderer. And let's look at that. So I just want to quickly set up the renderer because it's one of the features of this project. So I'm going to switch the renderer type to OpenGL renderer, and I'm going to turn on lighting, and then to this merge here with the camera in it, I'm going to add a 3-point light. Let's just let it sit in the middle like that. So then the spheres, which is shape 2 here, I want to come to their material and turn off receive lighting. And now you'll see that they're self-illuminated, and that's a kind of really easy little trick that we can use. You'll notice that this doesn't work if we switch to the software renderer. That's not available, but that's one of the tricks that we can do here. When we come to render it, we will need to change this transparency to sorted accurate in order for it to render properly. But that's way on down the line for now. So the next thing I want to do is to add a small cube inside the large one. So I'm going to make myself a little bit of space here. And after this merge, I'm going to add a 3D transform. I'm going to rename this as large. And then I'm going to add another 3D transform just to the flow area. Pipe this merge output into it, and then pipe that into this merge here. And rename this as small. So now I can use the small to have a scaled down version of it. So this small transform here, we can just come to that scale and set that value to 0.5. And now that cube is half the size of the main one. So then let's apply a sine rotation to this large cube. So let's add an expression to its Y rotation. So right click, add expression, and I'm going to do a very basic version of this. and build it up as we go. So sine, open brackets, time, times 3, close brackets. And I want you to see what happens with the cube. So it's juggling around like crazy. It's obviously only rotating between -1 and +1, which obviously is what we would expect from that sine function. So to get a larger angle, we need to multiply this by 60. So we can get a 60 degree rotation. But as you see, it's far too fast and it's not really very useful. So what I'm going to do is I'm going to put that time times 3 into its own set of brackets. So time times 3 in there. And then I'm going to add divided by, open brackets, 180 divided by pi, close brackets. And now I think you'll see that we've got a much more workable animation. So having done that, our numbers make a lot more sense. So if I were to come to frame 30, you can see that we've got our rotation of 60 degrees, which was our multiplier here. And the reason we're at frame 60 rather than frame 180 is because we've multiplied time by 3. So there at frame 60, we're back to 0. Our time is now kind of much more reflective of the actual rotation of the cube, because we've done this division by 180 over pi. So when dealing with expressions that involve rotation in Fusion, you always need to be aware of when you need to be in degrees and when you need to be in radians. So anyway, that's the rotation of our large box. I'm going to copy that expression, Command C, come to this small, which is our 3D transform, add an expression to the y, paste that in there, and instead of sine, let's use cos for the rotation of the small box. And now they look like this. So if we wanted the small box to move faster, we could change this time multiplier. So we could go for 4, for example, there. And so then we get a faster rotation of the small box. But really, this is just not a mathematically accurate simulation of anything. It's really just a kind of creative decision. So you can pick whichever time you want for either cube. So the really interesting part of this project is how we connect the strings that attach the corners of the small cube to the corners of the large cube. So the way I've gone about it is to add a 3D ribbon. Bring this ribbon over here and let's pipe it into this main merge with a light in it. Now, we want to do with this ribbon the same thing we did with our spheres on the corners, and that's turn off the lighting. So turn off affected by lights, and you can see that now that's going to be self-illuminated once we've sorted ourselves out. So we only actually want one line. We don't want a sort of multiple ribbon effect, and we want to increase that width quite a lot, and probably 10 is good, maybe even go for 15. We can always adjust that later on. The good thing about a ribbon is you've got a start and end, so you can attach the one end of the ribbon to one thing and the other end to another thing, and that's what we want to do. We want to attach it to this and to that at either end. But the problem we have is that our cube has only rotational information. It doesn't have any translation information which we can use to apply to these positional values for the start and end of the ribbon. Now, I could enter an expression directly into the fields for the start and end of the ribbon, but that would make it very hard for you to visualize exactly what's going on and where the issues lie. So what I'm actually going to do is to create some dummy objects that we can very clearly see as we're setting it up, and then simply link to those. It's a few extra steps, but I think it's worth it to enable you to get a clearer understanding of the method. So I'm going to make another 3D shape. Let's pipe it into our main merge there. And just for the sake of argument, I'm going to select cone for this. And let's set the radius to be 0.1 and the height to be 0.1. So it's really quite tiny. You can see it there. What I'm going to do is just going to make it bright green and turn off its lighting so it's always visible like that. So effectively, we want this to follow the rotation of the cube and give us positional information. So we can do that by selecting this large here and selecting that, so Command clicking both of them, open them both up so we can see everything. We need to come to the transform for that shape, that cone, and we also need to see the rotation of the large box. So what we're going to do is add an expression to the X of the shape, so right click, add expression, and we're going to pick whip that Y rotation value of the large box. So what we're going to do is we're going to put this expression into a sine function. So sine, open brackets, large blah, 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 close brackets. And now you can see that that is moving crazily backwards and forwards. And again, we need to do that operation where we divide it by 180 over pi. So we're going to come into here after the expression before the close brackets. We're going to divide by open brackets 180 divided by pi close brackets, and now that movement makes a lot more sense. And then we can copy this expression, Command C, add an expression to the Z and paste that in there, and as expected change this to cos. And now we have that cone describing an arc, and it does seem to be following, but it's not following on the corner of the object, it's sort of following on the face. So what we need to do is we need to come into this merge before these large and small and come to the transform and simply rotate it through 45 degrees on Y. And you'll notice that it's now on the corner, but it's still not quite working with our cube. And that's because we need to do something with the scale of the cube. So it's actually fitting within a circle that has a radius of 1. So to do that, we can come to the scale of this merge, and here in the scale, let's type SQRT, which is square root, open brackets, 2, close brackets. And now our cube has been scaled using Pythagoras, so that our little cone is now fitting on the corner of the cube. So I'm just going to disable a few things to make it a little bit easier to see for you. So I'm going to disable those spheres. Let's also disable that ribbon for the time being. And also I'm going to just detach that small box, just so we're not seeing that. And we're just seeing the big cube and our cone here. So what I'm going to do is I'm going to rename this shape as A0, and it'll become obvious in a second. So then let's add a 3D merge to it. We don't actually need to see this. This is just going to be a control object, but I'm going to show you as we build it up, just so you can verify that everything is going to plan. So I'm going to copy this A0, paste, and then add it to this merge, and then rename it as A90. So then I'm going to come into the expression, and what I'm going to do is I'm going to add 90 to the end of this, so before that division operation, so plus 90, and I'm going to do the same on the other one, so plus 90. And the reason that that's not working exactly right is that we need to enclose this in brackets, like that. So sine, open brackets, large blah, 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 dot y, plus 90, close brackets, divided by open brackets, 180 over pi, close brackets. And we need to do the same thing with the cos. So open brackets there and close them there after the plus 90. And now, hopefully you can see we've got our other control cone on this edge here. So let's do the next one. Command C, Command V, add it to the merge. This one we'll call A180 and come into here. And instead of 90, we'll have 180 and 180 there. Command C, Command V, add it to the merge. F2 to rename A270. Come into the expression, change the 180 to 270 there, and to 270 there. So now we've got the control objects for our large box, and we can duplicate them and create the control objects for the small box. So I'm going to take all of those, Command C, Command V, I'm going to pause while I rename them as B rather than A. So now you can see I've renamed those as B0, B90, B180 and B270. I'm applying them all to that merge. It's all getting a bit messy. Let's move all those out of the way like that so we can concentrate on these. So let's re-enable or rather patch our small back in again so we can see that, and maybe disconnect the large actually so it's not confusing us. And indeed we can completely disconnect all of these A values. We don't actually need to see them. So let's now concentrate on the B's. So let's come to B0. So we need to swap out large for small in the text there. Large, small. And then just divide the result of everything by 2, because our small cube is half the size of the big one. So I've done that for both x and z, so in other words sine and cosine. So now you can see that our first one is sitting where it ought to sit. So we just need to go through and do that with all of them. So this is B90, so change large to small, divide by 2, large to small, and divide by 2. Select a B180, and then large needs to be small, and then divide by 2. Large needs to be small, divide by 2. And the same thing with the last one. Large needs to be small, divide by 2. And large needs to be small, and divide by 2. So now we've got our control objects for our small cube as well. So now we're kind of cooking with gas, and we can actually work with our ribbon. So we can re-enable that ribbon, and let's reattach that large. So then I want to make sure I can see my ribbon object and my A0. Command click them both so I can do some pick whipping. So as I say, we need to attach the start and end to the relevant control objects. So I'm going to add an expression to the start here, expression, and I'm going to pick whip the X value for the A0 object. And then we can copy this expression, Command C, add an expression to the Z, paste that in there and change the X to a Z. So now you can see that that's attached here to the upright of the cube. We actually want it on the top of the cube, so coming out of this corner here rather than the middle. And we can do that by adjusting that Y start value. Again, we need to consider the square root factor. So sqrt open brackets 2, close brackets divided by 2. And now hopefully we can see that it's attached to this top corner here. That's because we were putting our cube inside that circle with a radius of 1. So that's why we need to use the square root there. So then all we need to do is we can copy this expression. So add an expression to the X end, paste that expression in there. And instead of A0, we simply want B0. So let's copy this, add an expression to the Z and paste it in there. Change that to Z. And now you can see that our line is attaching to the little cube and to this control object here. Let's now disable that control object because we just don't really want to see it. It's a little bit annoying. So let's disconnect that. And you see that again, we're attaching to the middle of the cube. So here we're going to type, for the Y, we're going to type sqrt open brackets 2, close brackets divided by 4. And now it's attaching to that top corner of the cube there. So that was a lot of setup, and you're probably thinking there's a horrible amount of work still to do, but actually now it's really quite easy. So after this 3D ribbon, I'm going to add a new 3D merge to keep things tidy. And then I'm actually going to hide all this stuff here because we don't need to see any of this. So let's grab all of those control objects and then Command G to group them because we can work off this one ribbon here. So Command C on that ribbon, Command V, paste it into this new merge here. And so it's really quite simple. We just need to come through and adjust these values. So instead of A0, we need A90. So that's for the X and the Z. Instead of B0, we need B90 and B90. And now we're attached to that other corner. Hope you can see that. Actually, you know what I'm going to do is I'm going to, after this merge, I'm going to add a replace material so we can see these lines a little bit more easily. So add a replace material in here. Let's come over here and let's again make this completely green, I think, like that. So we can very clearly see these lines as we're adding them. So you can see how very, very easy it is to add these lines. So Command C, Command V, add it into the merge. Again, swap this number, so 180 instead of 90 in each case. And down here as well. Down here as well. Now we've got that other corner attached. Command C, Command V, pipe that into there. Instead of 180, we want 270. 270 in here, 270 in here, and 270 in here. So we've got all our top corners attached. And then we can very, very easily attach the other corners. So we can select all of these, Command C, Command V. Let's merge all of those together into their own merge, I think. Just keep it a little bit tidier. Let's move that out of the way. Let's merge this with that merge. And so let's come into this first one here. So really the only thing we need to do is adjust this Y position, and we only need to add a negative sign to the start of it. So negative there, and you can see we've made that bottom connection there. So literally just whiz through and add negative sign in front of those Y values. And do the same for the remaining boxes, and I don't need to show you that in real time. And so now our entire rig has been set up. And let's just turn back on our spheres at the corner to get the full effect. So there you go. I think that's probably more than enough for the time being. If there's enough interest in this tutorial, I will certainly come back and show you how I styled the whole thing. And also there's a kind of thing I did where I ramped the start and end of the rotation of both cubes just for more visual interest. That's quite another interesting little use of expressions there. But as I say, I think that's enough for now, and thanks for watching so far.